All right, let's jump right in. Sometimes the most profound ideas come from the most unexpected places. Today, our source is, believe it or not, a sixth grade math worksheet. But I promise you, this is not your average homework assignment. It actually wraps a simple math problem inside this epic story of survival, scarcity, and thinking on a scale that is just massive. So, that really gets to the heart of what we're exploring today. We're not just here to crunch numbers. We're going to see how framing a problem with a story, with real stakes, can completely change how we think about numbers and the incredible power they really have. So, picture this. We're in ancient Egypt. The source material puts us right in the shoes of Joseph, and his job is to manage the entire nation's food supply during a terrible famine. I mean, we're not just talking about inventory here, we're talking about managing a nation's survival one calculation at a time. The setup is pretty straightforward, but wow, the scale is huge. You've got this massive, carefully built-up stockpile of grain on one side, and on the other, a devastating famine, a total crisis. The only thing standing between order and chaos is precise, large-scale math. So just how big are we talking? 900 million. Just take a second and look at all those zeros. 900 million bags of grain. That's our starting point. That's the resource that's supposed to keep an entire civilization from starving. It's a number so big it's kind of hard to even wrap your head around. And here's the other side of the coin. This is what's going out the door. 123,456,789 bags. And notice, it's not a nice round number. It's messy, it's specific. It represents the real, complicated needs of a lot of people. So the big question is, what's left? And that brings us to the math problem at the heart of it all. How in the world do you subtract a complex number like that from a huge, simple number that's mostly just a sea of zeros? It's actually a lot trickier than it looks. Okay, so when you line it up like this, you see the problem right away. You have to subtract 9 from 0. Can't do it. So you try to borrow from the next column, but that's a 0 too. And the next one? Also a 0. You have to go all the way down the line to that 9 to get anything to work with. To solve this, you need a very specific move. And of course, that move is called borrowing. We all learned this in school, right? But here, we're doing it on this grand, almost ridiculous scale. You have to take value from that single 9 way over in the 100 millions place and let it cascade all the way down, column by column. So here's how it works. Dot 9 becomes an 8, which loans a 10 to the next column, but that column has to loan to the next one, so it becomes a 9, and on it goes. It's this incredible chain reaction of 9s all the way across until you finally have a 10 in the last column to do your subtraction. It's a really cool little algorithm when you see it in action. And after all that, there it is. That's what's left. 776,543,211 bags of grain. That is the new number. That's the buffer they have left, all figured out with total precision. Okay, so we've got the method down. Now, the worksheet doesn't just stop there. It wants to make sure we've really got it, so it throws a few more scenarios at us to kind of stress test the strategy. Let's do a quick rapid-fire round. First one, a billion minus, well, almost a billion. This is that classic borrowing across the zeros problem all over again. And the answer? A surprisingly clean 12,345,679. You can almost see the pattern emerge. Next up, something a little different. No huge strings of zeros here, but you still have to be super careful with your borrowing. And the result? Look at that. 332,223,333,333. A very satisfying number. Okay, last one. 500 million minus this big, messy number. We are right back where we started, structurally speaking. And the final answer is 154,321,877. So yeah, the method holds up. It works every time, no matter how big the numbers get. But then, right after we've mastered these huge but ultimately finite numbers at the very edge of what we can imagine, the worksheet does something really interesting. It pivots. It asks us to think about what lies beyond calculation. It gives us this quote, and suddenly the focus shifts. We go from things that can be counted, even if it's in the hundreds of millions, to something that is by definition immeasurable. And that's really the big takeaway from this whole thing. By making us wrestle with these massive, tangible numbers, it's actually preparing our minds to grasp the concept of something infinitely bigger. It's like it builds a bridge from the purely mathematical to the metaphysical. So, I'll leave you with this question to think about. We didn't just subtract two numbers today, did we? We calculated the fate of a nation. We didn't just do homework problems, we stress-tested a survival plan. And it just goes to show, when you give numbers a story, they stop being just symbols on a page and start being what they really are: powerful tools for making sense of our world.